Hello, this is G.O.M. Kedareshwar Kiran from Electrical Department of 5th SEM. Today I am presenting about modern insulation materials for 400 kV transmission lines. 400 kilovolt transmission lines, which is very heavy transmission line. What are the causes of modern insulation materials and what are the materials? Let us go into the slides. Modern insulation materials for 400 kV transmission lines. Presenting explore the critical role of modern insulation materials in 400 kV power transmission. So the power generation happens, power transmission happens, and power distribution also happens. Then we get into use. The importance of the electrical safety is reliability and performance. We all know into current material involves innovations, and as 2025 there are modern techniques of insulation materials. So role of insulators in 400 kV transmission lines. What are the role of insulators? Generally, the insulators are kept with before olden days we used to get before some years as a brownie coil disc type. Now the brown coil changed into glossy finish, glass finish insulators. I, isolation isolates conductor from towers and ground prevent leakages. These insulators prevent the leakages and stress resistance must withstand high electric, mechanical, and environmental stress. System integrity ensures system integrity and reduces outage risks. As we know, the insulators are very important for the transmission lines, which help for the leakage current and the ductility and different types of errors. So traditional insulation materials, on the right side we can see the brown color disc type coil materials. It is a brown color coil with a glassy finish. It is a modern insulation. Nowadays we use this glassy finish in the transmission lines. It is called porcelain and glass. Porcelain, it is made up of porcelain material and glass. So porcelain insulator, what are the porcelain insulators? Fried clay and high fried clay. Fried means it is like combusted clay with high mechanical and dielectric strength, commonly used for voltages up to 400 kV. These withstand up to 400 kV. So these actually a brown normal disc type is more less cost than the glossy finish porcelain insulator. Advantages are mechanical and resistance temperature changes. It also resists up to high resistance and glass insulators. Tempered glass with high dielectric strength. Dielectric means the field strength between the transmission lines, the aluminum conductors. Long service life used up to approximate 33 kV, but still relevant to some applications. Not up to 33 kV, but still approximate value, nearby value. Advantages: transparency and deflecting, general lower cost. It is mainly transparent and the leakage current can be easily detected with detectors and machines. So this traditional insulating material, on the right side we can see the insulating material picture. It is a glass finish insulator, porcelain glass. And porcelain insulators characteristics and benefits. What are the characteristics and its benefits? Material composition, typically made up of silicone rubber. EPDM, EPDM means ethylene propylene dine monomer. Actually I am not aware of it, I'm sorry. But other advanced composite polymers. Polymers means generally the rubber type materials. And hydrophobicity. Hydrophobicity means the surface reduces effect of the combination contamination and such the direct and moisture accumulation. Generally on that much top of transmission lines, the moisture is atmospheric pressure created due to the moisture, and it accumulates some moisture. Such contamination effects reduces significant hyperphobicity. Easy of use, lighter weight design leads to easy installation and reduced maintenance requirements, offering life cycle cost effectiveness. Higher voltage used increasingly development. Higher voltage applications now suitable for lines up to 800 kV due to their superior performance. Their superior performance means lines up to 800 kV. We generally don't see the 800 kV in city areas. the long rural and village areas, we can see those 800 kV lines. So composite insulators for ultra high voltage lines, composite insulators for engineered ultra high voltage UHV. Generally the high voltage DC transmission occur HVDC, that is called, and this one is ultra high voltage line, and featuring reused glass fiber and encapsulates within the proximity of housing. The construction provides the exceptional material and strength and superior directive performance crucial for the ultra high voltage applications. They are not reduced as an inductor swinging through a strong conditions, thereby improving overall system stability. Furtherly, more impact design and construction and streamlines for the towers ensures improved conductivity, clearance, and contribution of more efficient transmission networks. So now challenging in installations at 400 kV and above. What are the challenges we face in installations above 400 kV and up to the 400 kV? First thing is dielectric strength. Maintaining exceptional high dielectric strength to prevent electrical breakdown under immense voltage stress, and environmental resistance, ensuring resistance to harsh environmental contaminants includes dust, heavy rains, and ice, and industrial pollution. These are general things. And thermal stability requirement materials excellent thermal stability to withstand heat generated by the conductors, prolonged exposure UV radiation. So the thermal stability uh, means how an object can withstand with the prolonged UV radiation caused from the sun. Generally flashover and flashover risk across the insulator surface and diverse conditions. Flashover risk means the mobility of the system enhancement. So now innovations, composites insulation across arms, enhanced design. These innovates cross arms directly replaced traditional steel structures and complex insulator string. Simply the tower design reduce impact by reducing the tower height and minimizing visual clutters. They significantly improve public acceptance and aesthetic integration. Landscapes means the power transmission line needed space to establish. Improved clearance means increase in conductor height and approximately 4 meters, enhancing ground clearance and safety. Power capability, the design allows the greater conductor sag. Sagging means the lagging of the potential mechanical strength of the wire, which translates to higher power transfer capacity across the transmission lines. And material advances in polymeric insulation, nanocomposite, self-heating polymers, flashover resistance, and eco-friendly solutions. Advanced nanocomposites bring developed significant enhance the strength and the thermal mobility. Self-handling polymers, the self-handling polymers are proposed to temperature irrelevant performance and emerging. Flashover resistance enhance the surface flashover, reduce the HVDC. HVDC means high voltage DC current and AC electrical stress and key focus. Research programming and biodegradable and environmental friendly insulating liquids for transformers. Transformer liquids means oils for the insulation purpose. It is the main thing. So design considerations for 400 kV insulators. Optimizing the design crucial, prevent surface arcing and long-term electric integrity. Polluted environments, the delicate balance must be struck between the insulator mechanical strength and the capability. Electrical insulation performs the support and heavy conductors withstand the environmental performances. These design contaminants the clearing of the maintenance and optional network uptime. So standard compile and maintenance compile between the mechanical and electrical difference, delicate environmental forces. So now what are the conclusions and future outlooks? Modern insulation materials combine mechanical strength, electrical reliability, and environment reliances. Composites up to polymeric insulation are up to 400 innovation and 400 kV and higher voltage transmission line. Ignoring research and is heavily used on enhancing sustainability, improving performance, and enabling more compact infrastructure designs. These advanced and absolute essential the global expansion of upgrading the high voltage transmission networks. Generally, these are the conclusions and future outlooks. Thank you.